Hi everyone, we're going to look at the 3.0 learning targets for Unit 8 and go through these together. So for 8.3.1, there's a lot of different types of questions that we could see. So for this first one, if arc BC measures 85 degrees, so I'm going to label that on here. So BC is this arc right here. So that is 85 degrees. And I'm trying to find the measure of arc AD. So AD is this one, and I'm going to just put a variable there, and I'm going to say X. So I am given the measurement between those lines when they meet at point E. So to set this one up, because this angle is on the outside of my circle, I need to find the difference of these two measurements. So difference means subtract. So I'm going to do 85 minus X. When I subtract those, then I would divide it by 2, and that will give me this angle. And so I know that that angle is already 30, so that's how I can set up my problem, and I want to solve this for x. So if all of this is being divided by 2, if I want to undo that division, I can multiply by 2 on both sides. So then this 2 and this 2 will end up canceling each other out. And I did run out of space, so I'm gonna try to write a little bit smaller. So I have 85 minus x equals 30 times 2, which is 60. I'm going to subtract 85 from both sides. When I do that, this minus sign is connected to my x. So I still have a negative x equals, and then 60 minus 85 is a negative 25. I don't want a negative variable, and so if a negative x equals negative 25, then I know a positive x equals a positive 25, which I could also realize that there's an invisible negative 1 in front of my x here, so divide this by negative 1, divide this by negative 1. That is how I get my positive 25. Looking at the second one, these two lines intersect on the inside of a circle, not at the center. So I know that I can add this angle or that measurement as well as this measurement, so this one over here, together and divide by 2, and that will give me this question mark. So I'm going to do 19 plus 107, and I need to divide that by 2, and that will give me this. Now, even though that's not the value of x, that it is helpful because I know that this missing measurement and my x are supplementary. They make up a straight line, so I know that these values will add up to 180. So 19 plus 107 will give me 126. So I have 126 divided by 2. Well, 126 divided by 2 gives me 63. Did want to save a little bit of space there because I ran out of space on the one left of it. So I know that this is 63 degrees. And I know that x and my 63 will add up to be 180. So I can do 180 minus 63 is going to give me my value of x. So 180 minus 63 is 117. For the last one, if the measure of angle DBA, so DBA is this measurement here, which is 68 degrees, what is the measurement of arc BA? So I'm trying to find the measure of this arc. So since this angle is made up of a tangent line, and it has part of a circle, part not of a circle, all we need to do with this 68 is double it. So we're going to do 68 times 2, and that will give us the measure of arc BA, and 68 times 2 is 136. All right, our next learning target, we're looking at 8.3.2. So it says find the measure of angle BCD and the measure of angle ACE. So to start, I do notice a couple things. I notice that this looks like it is a straight line. So that means that 40 and C are supplementary. So I can take my 180, subtract 40 from it, and that will give me that angle on the inside there. So 180 minus 40 is 140. So this is 140. So we actually just found the measure of angle BCD. BCD is 140. Now I also know that all of these added together will give me 360. But I could also do the same method here because again, if this is a straight line, this, I'm just going to do an X there. My X in 130 will also add up to 180. So I'm going to do 180 minus 130, and that will give me my X. Well, 180 minus 30, or 130, I'm sorry, is 50 degrees. So the measure of angle ACE is 50 degrees. Moving on to the one over here, it says find the area of the shaded segment. So what we want to do is we want to find the area of the entire sector, that is the triangle and the segment combined, and then we're going to find the area of just the triangle and subtract those two. So I'm going to try to do some notation here. So I'm going to do my sector minus my triangle. So the area of my sector is pi r squared times theta over 360. And then the area of my triangle is 1/2 base times height. So I'm going to do each area separately and then subtract them at the end. So my radius is 16. So I have pi 16 squared. My central angle has a notation that lets me know it's 90 degrees because it's a right angle. So I have 90 over 360. I'm going to finish this first and then we'll talk about the triangle. So I want to type this whole thing into my calculator here. I have pi and then 16 squared, 90 divided by 360. So the area of my sector is 201.06. And that would be, let me grab a different color real quick. That would be all of this. So the empty triangle and the shaded segment. So now I'm going to do my triangle. Since this is a right triangle, it's nice because my base is my radius, but my height here is also my radius. So I know my height is also 16. So I have 1/2 times my base of 16 times my height of 16, and I can figure out the area of my triangle. And I get 128. So now I just want to subtract those two numbers because I'm taking my triangle out. So I just have the area of that shaded segment or piece left over. So 201.06 minus 128 gives me an area of 73.06, and that would be units squared. All right, we got two more 3.0 learning targets. So this one says, Elena is about to perform a relay handoff on a circular track that has a radius of 6 meters. Her track partner, Jaden, is standing 43 degrees away from her. How many meters does Elena need to run on the track in order to pass the baton to Jaden? So the first thing we want to figure out is if we are doing excuse me, area of a sector, or if we're doing arc length. So if we have a circular track and Alina needs to run on the track to pass the baton, so we have a circular track. If Alina is here and my hand's in the way and running around the track to get to Jaden, we're looking for our arc length. So I know, I'm just going to kind of add some things in. I know my radius is 6. And I know this drawing is not to scale, but that's okay. And I know that my central angle is 43 degrees. So I'm going to use my formula 2 pi r times theta over 360 so I can get that arc length. So 2 times pi times my radius times 43 over 360. And I can type this whole thing into my calculator. So here I have 2 pi times that times my fraction, and I get an arc length of 4.5. Since I am using meters, it's going to be 4.5 meters. For the very last one, we are given a circle, and we need to write the equation of that circle. What's nice about this one is the center is already labeled for me. If it wasn't labeled, we can see where the center is here with the point. So if my origin is here, I know my x value is -2, and then I have to go up 3, so my 3 is positive. So that's where the point comes from. If it's not given to you, find that first and write it down. Now, I also want to look at what my radius is. So my radius, I'm going to go from my center to an outer edge. I'm going straight across so I can just count the number of boxes. So I have 1, 2, 3. So I know that for this, my radius equals 3. So for my equation, I have, I'm going to write the template up here actually first. If you know this template, you can just plug in your h and your k, which is my h is -2, my k is 3, and then my radius is 3. I can plug that in there. Or if you don't remember this formula, I know that x needs to go with the x value of my center, and it always is the opposite of what it really is. So if the x value of my center is -2, I know it needs to look like a +2 inside my parentheses. I need an exponent on the outside of my parentheses. Then I have plus. For the y value of my center, it was a +3, so I know that it has to look like a negative. So I'm going to use -3 inside parentheses. That is being squared. And then it's going to equal whatever my radius is squared. 3 squared is 9, so it equals 9. And we have our equation. Hopefully that helps with some of the 3.0s.